Hi, this is Dean Collimer with an Agronomy Minute. Today I'd like to share with you about soil pH and liming. Soil pH is a key characteristic of soils. pH defines the acidity or basicity level in the soil. The importance of soil pH can't be overstated because soil pH governs its chemistry and biology. Thus, pH impacts plant growth and yield. What is soil pH measurement? It's a numerical measure of hydrogen ion concentration in solution. It's a chemical scale that runs from 1 to 14. Lower soil pH has more ions. Higher soil pH has less hydrogen ions. Most crops grow best in the slightly acid range of about 5 to 7. Legumes like alfalfa and soybeans need soil pH in the upper end of this range, about 6.5 to 7.
What happens when you ignore soil pH and have levels lower than the crop needs? As you can see in this first dramatic cornfield photo, there is variable growth. The differences are directly related to soil pH. In poor-looking areas, the soil pH is about 5.3, stressing the crop severely. The second close-up photo shows multiple nutrient deficiencies, typical of low soil pH. See the little white spots on some of the lower leaves? This indicates magnesium deficiency, which is at such a low level the plant can't manufacture chlorophyll, essential for photosynthesis. Bottom line, when trying to grow top yields on fields with soil pH levels outside the ideal range, crops will struggle. Additionally, plant nutrient resources will have reduced effectiveness as their movement to the roots and plant uptake is limited. This generates lower yields, profitability, and increases likelihood for environmental losses.
Changing soil pH can influence nutrient availability to plants. Here's a chart that illustrates how each plant nutrient behaves across the pH scale. The width of the bar shows availability. Wider bars, greater availability. Narrower means lower availability. Agricultural lime can remedy low soil pH and creates additional benefits. Let's go through a list here. Ag lime reduces toxicity of aluminum, manganese, and iron. It improves the physical condition of the soil to a more desirable granular form and structure. It stimulates microbial activity. It increases the cation exchange capacity. It increases the nutrient availability of several key nutrients including nitrogen, phosphorus, calcium, magnesium, sulfur, and boron. And itself supplies calcium and magnesium. And it improves nitrogen fixation by legumes. A liming material, or one that increases soil pH, must have calcium in the carbonate, oxide, or hydroxide form to create the liming reaction that increases soil pH and decreases acidity. Calcium and magnesium in lime are very slow to leach through a typical silt-loam soil profile. In today's crop management with routine use of no-till, an important constraint when using no-till is that lime moves very slowly down into the soil profile, only about a half to 1 inch per year. Monitoring pH and advanced planning for liming when no-tilling is very important due to that limited soil mixing when applying lime. In summary, soil pH is the foundation to effective nutrient use for crop reduction. Correcting soil pH to crop-specific ranges is a priority before turning attention to the other nutrients, NPK, secondary, and the micros. See your local GROWMARK FS crop specialist for starting off right with soil testing, pH management, and liming to reach your crop yield and profitability goals.